Hello everyone, this is Mrs. Leong, and this is Algebra 1, Lesson 10.4, Radical Equations. All right, so today we're going to learn how to solve a radical equation. Basically, equations that contain variables in the radicand are called radical equations. All right, so something, like Example 2, this is a radical equation because your variable is inside that radical. All right, so to solve, you're going to isolate. You're going to isolate the variable, or actually first thing you want to do is you want to isolate the radical on one side of the equation first. All right, so get the radical all by itself on one side of the equation. Everything else goes on the other side. And then you just square both sides to solve for the variable, because squaring both sides will eliminate the radical, allowing you to just solve for the variable. All right, so the property we're using here is called the power property of equality, which basically says that if you square both sides of a true equation, the resulting equation is still true. So if a is equal to b, then a squared is equal to b squared. All right, so we're allowed to square both sides of the equation, and that equality remains true. All right, so let me show you guys some examples. So here we have our example where 16 is equal to rad x over 2. And so we want to go ahead and isolate the radical first. All right, so here's my radical. So to isolate, I'm going to go ahead and multiply both sides by 2. Let me go ahead and work this out on the side so you can see my steps. So I'm going to multiply both sides by 2. So that way I can isolate the radical. So I just have rad x on one side, and then I have 32 on the other side. And then to solve for x, now that I've isolated the radical, I can square both sides of my equation. So that leaves me with just x, and 32 times 32 gets me 1,024. So that would be your final answer. All right, let me show you another one, example 2. All right, so I have a radical equation because I have my variable inside the radical. My first goal is to isolate the radical. So I want to get this guy all by himself. So I'm going to subtract the 2 on both sides. So I have rad 4x minus 7 is equal to 5. All right, so now that I've isolated the radical, I square both sides to eliminate that radical. So on my left, the square eliminates the radical, so I'm left with 4x minus 7. And on the right-hand side, 5 squared gets me 25. And now you just solve for x. So add 7 to both sides, and then solve for x by dividing by 4. And that is your final answer. All right, so we solve for x, and that x, we know when you plug that in right there, that this equation now will be true. Okay, so let's go ahead and see if you guys can try a few. Let's go to, we're going to jump. We're not going to do all of these. Let's jump to number 7. All right, let's have a look at number 7. Okay, so we have our variable inside the radical, and it's already isolated. I know I have 2 radicals here, but I'm really focused on the one with the variable inside. All right, so I want to isolate that one first. So since it's already by itself, I'm going to go ahead and square both sides so that I'm left with just y on my right-hand side. On the left-hand side, my 2 gets squared, so that's 4. My rad 3 gets squared, so that just gets me 3. So 4 times 3 gets me 12. And that is it. Okay. Let's see if there's any other ones, I think. let's do number 14. That one looks like it could be a little scary. All right, so I got rad x over 2 is equal to 1/2. Again, first step is to isolate the radical with the variable. All right, so that radical is already isolated. It's all by itself on one side. So to eliminate the radical, I'm going to square both sides. And I get x over 2 is equal to 1/2 times 1/2, which is 1/4. Okay, so I'm going to multiply both sides by 2 to solve for x. So I get x is equal to 1 over 2. Okay, and that is it for number 14. Okay, so why don't I have you guys try a few just to check on your own, and let me have you go ahead and practice with, let's see. All right, let's do number 3. Let's do number 13 and 15. All right, so 3, 13, and 15, try those 3 on your own. If you finish early, go ahead and you can check with a neighbor and see if you guys got the same thing. And go ahead and pause this video, and once you're ready to check, you can unpause and see if you got it. All right, so if you're ready, here are the answers for those 3 problems. So number 3, answer was 16. X is equal to 16, and there's my work. Isolated the radical, and then squared both sides. All right, and then number 13, I got 10 over 3, 10 over 3. So that was my work there. Just to show you a little bit of the work behind here, how I got 12. It was 2 square, which got me 4, and then rad 3 square got me the 3. So 4 times 3 got me 12. And then I just subtracted 2 and then divided by 3. All right, and then number 15, answer was 128. Okay, isolated the radical. It was already isolated, so I square both sides to get rid of the radical, and then I just solve for x. All right, so that is the first part of our lesson to solve these radical equations. Okay, let's go to our second half here. And it's kind of more the same, except I want to introduce you guys to this concept called extraneous solutions. Extraneous solutions. So what an extraneous solution is, it's an extra solution. All right, so it's a solution that's actually not really a solution. Okay, so let me explain. To solve a radical equation with a variable on both sides, you need to square each side of the equation. All right, so we've been doing that. We've been squaring both sides, but in the beginning here, we only had a variable on one side of the equation, right? All of these only had a variable on one side. We have to be careful when there's variables on both sides, like this example 3. I have a variable inside the radical here. I also have another variable on the other side of the equation. So what happens when I square both sides is sometimes I get what's called an extraneous solution. Okay? And what that means is there's solutions that are not solutions to the original equation. So to avoid getting extraneous solutions, because we don't want them, we have to check our answers once we've solved. All right, so it's just one extra step of checking your solutions. So let me show you kind of how that sometimes happens. Okay, so let me show you this example right here. Let me recreate it on the side. All right, so if I were asked to solve for x here, and I see I have variables on both sides of the equation, first thing I'm going to do is I'm going to isolate the radical just like before. Make sure that radical is all by itself. Next, I'm going to square both sides to eliminate the radical. All right, so on the left-hand side, I get x plus 3. On the right-hand side, please make sure you multiply that out. This is x minus 3 times x minus 3. Do not distribute that exponent. This is not equal to x squared minus 9. No, 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 no. Okay, that is not correct. So we're going to distribute this, and we're going to FOIL it out. So I get x squared minus 3x plus 9. Combining these two, I get x squared minus 6x plus 9. All right, and my left-hand side is the same. And now I have a quadratic, okay? And we had a whole chapter about solving quadratic equations. So we know to set one side equal to 0. So I would subtract x and subtract the 3, subtract x, subtract the 3. So I get 0 on one side, that's what I need. And then I can factor what I have left. So x times x gets me x squared. Negative 6 and negative 1 multiplies to positive 6. When I cross multiply and add, I get my negative 7x. All right. So this factors out to be x minus 6 times x minus 1. Solving for that, this one, if I set that equal to 0, x is equal to 6. If I set this factor equal to 0, that gets me x is equal to 1. Now usually you would just box your answer, call it a day, but again, we have to check for extraneous solutions. So check by plugging it into the original equation, okay? So here is your check. All right, my original equation was rad x plus 3 is equal to x minus 3. So let's check each of these answers. Okay, so if x was 6, I have rad 6 plus 3 is equal to 6 minus 3. Plugging in 6 for this x and this x. Let's make sure that's true. So I have rad 9, which gets me 3, and 6 minus 3 is equal to 3. All right, so this is a solution. That one checked out. Okay, let's try this one. X is equal to 1. When x is equal to 1, I'm going to plug that in. I get 1 plus 3 is equal to 1 minus 3. All right, plugging it in for this x and this x. And I get rad 4, which is 2. Ooh, but this side I get negative 2. So this is not true. So x is equal to 1 is an extraneous solution. So I want to toss that one out. So my only solution is x is equal to 6. All right, so that's what we mean by extraneous solution. We get some x's that actually don't work because we squared both sides. Okay, let me show you one more and then I'll have you guys try one. All right, so example 4. First, I see I have variables on both sides of the equation, one inside the rad, one outside the rad. So that tells me I'm going to need to check my solutions, and in the directions, they even tell you to. So that's nice of them. All right, I'm going to isolate my radical that has the variable inside, and good thing I already have it isolated all by itself. So I can go ahead and square both sides. So I get t plus 5 is equal to t plus 3 times t plus 3. I'm going to FOIL this out, so t squared plus 3t plus 3t plus 9. And my t plus 5, still the same on the left. All right, keep simplifying on the right-hand side. And now let's get everything equal to 0 so I can solve for my t. So I get t squared plus 5t plus 4 on the right-hand side. Okay, let's factor this guy. So I got t times t gets me t squared. Positive 4, positive 1 multiplies to get me positive 4. And when I cross multiply, I get 1t plus 4t is equal to 5t. All right, so that checks out, which means this factors out to be t plus 4 times t plus 1. Okay, and that gets me t plus 4 is equal to 0. So t is equal to -4, or t plus 1 can equal to 0, and t is equal to -1. All right, so my last step is just to check my solution. So let's check here. My original was square root of t plus 5 is equal to t plus 3. Let's see how these guys check out. Okay, so when I plug in -4, let's see what happens. I get rad -4 plus 5 is equal to -4 plus 3. I get rad 1, which is 1. And this gets me -1. So this is not true. I'm going to toss this one. Okay. Now, that doesn't automatically make my next one true. It is possible to get no solution for these. So you do have to check both. So plug in -1. Let's see what happens. I got rad 4, which is 2. Oh, and -1 plus 3 also equals 2. So this one actually does have a solution. All right, so t is equal to -1 is your final solution. All right, and that is it, how you do it when you have variables on both sides. Okay, let's have you guys try one on your own. Let's do number 8. All right, let's have you guys try number 8 on your own and see if you can do it and see if you got it, okay? So go ahead and pause this video. Once you are done and you're ready to check your answer, unpause, and then you can check your answer. All right, so if you're ready for number 8, here is the answer. And this time we actually had both of them work. All right, so answer was -2 or 1. -2 or 1. So I squared both sides, all right, and then I simplified it down to this. Then I subtracted 3b, subtracted 6. So I get one side equal to 0, which I need to do before I factor. And I factored it to be b plus 2 times b minus 1, giving me solutions of -2 and 1. And when I checked -2, it worked. 0 is equal to 0, that's true. And when I plugged in 1, 3 is equal to 3, that one worked. So I actually got 2 solutions on that one. All right, and that is it for lesson 4.